This video is for the Unit 1 Skill 8 formative key. So we've transitioned in class to working with these applications of the derivative. We are focusing at this time on the first derivative. And we can always think about it this way, that the function f gives us values and f prime gives us slopes. And then we'll learn that f double prime will give us shapes. So in the level 2, it asks us to take an f prime graph and state where the original function is increasing or decreasing. So increasing or decreasing are questions again about the slope. This graph though, and I always have to be mindful now in these graph problems of identifying what this is a graph of, is telling us that this is a graph of the slope. Therefore, wherever our graph is positive, our slope is positive. So we are increasing over the interval from -1 to 1.5. Where are we decreasing then? Well, we're decreasing wherever our slope is negative. And since this is a slope graph, then we are decreasing over the following intervals. -3 to -1. And again, from 1.5 to 5. At level 3, it takes a similar approach, except now it talks about concave up and concave down. Again, this is an f prime graph. Well, concave up and concave down are questions about the second derivative. So I can think about this problem this way. The relationship between the function and the first derivative is analogous to the relationship between the derivative and the second derivative. So if I want to have concave down in this setting, I can be thinking about this as where was it decreasing? Or concave up, where was it increasing? If I'm thinking about this as f. So, here we go. We are increasing here, here, and here. Therefore, we are concave up from -3 to -2, from 1 to 3, and I've got to break that interval so it's also from 3 to 5. Why? Because at 3 I have a corner, and at corners I am not differentiable. And since I'm analyzing f double prime, that is the derivative of f prime. How about where I'm concave down? Well, that'll be wherever I am decreasing. In this case, I am concave down from -2 to 1. And there's my answer. Finally, the level 4, I am given information, and I'm asked to sketch a graph. I may remember back to objective 1 where I was given a graph with, I was given a table with functional values and with f prime values. Now I'm given f prime values and f double prime values, and I'm given 2 points. F of 0 equals -3, and f of -2 equals 4. Okay, so here we go. In class, I started showing you your good friend x squared and -x squared. And I framed them through the lens of the derivative. If y equals x squared, y prime equals 2x, and y double prime equals 2. And if y equals -x squared, then y prime equals -2x, and y double prime equals -2. So what we said in class is the following. If I have a positive second derivative and a positive first derivative, well, that would happen right here. Positive first derivative, positive second derivative. Or if I have a negative first derivative and a positive second derivative, that would look like this over here. Or if I have a positive first derivative, but a negative second derivative, that would look like this. Positive first derivative, negative second derivative. And if I have a negative first derivative and a negative second derivative, it'll look like that. Now, what this setup does for me is it gives me a nice way to be able to take this information and say, okay, I need to sketch a graph, no problem. Because from negative 5 to negative 2, I should have a positive first and a negative second. I should look like that. So that is what my graph should look like there. And there I messed it up again. It's okay, I'll fix it up here. Third time's a charm. And then for negative 2 to 0, I have a negative first and negative second. That looks like that. But I knew that it needed to go the whole way down there to negative 6 to go through that point. So I need to get much steeper to my slope. And then I'm positive from 0 to 2. That looked like that. And then from 2 to 3, I have a negative first and a positive second. That looks like that. So I get a little cusp action. And then from 3 to 5, I'm negative again. And I look like that. So this is one possible example of a graph that fits these criterion, goes through those points, and has all those first and second derivative characteristics.